Welcome to Networking Part 2. Today we're going to be talking about protocols, ports, and the OSI model here. Also, don't forget to subscribe. I'm going to be putting out videos as often as I can for the cybersecurity class here. Really helps the channel out. Today's going to be a short class. We're going to talk about common ports. Also, we'll talk about the OSI model, what it is, and the different parts of it. And we'll talk about something called encapsulation. So what is a protocol? A network protocol is just a set of rules that determine how data is transmitted between different devices. So if you're sending a picture versus logging into a service or sending a password, these are all different protocols. So if you're using Wi-Fi, that's a different protocol. Or if you're using encryption, these are all different, ways of sending data. So networks, they use these different rules to make sure data and messages are sent in the way that they want to. So each protocol has its own rules or specifications. So HTTP, this is how we access websites. HTTP has its own rules on how websites are served, how we access them, and how they're sent across the network. Even iMessage has its own protocol. So if you're an iPhone user, iMessages has its own proprietary protocol. How is one message sent to the Apple servers and then back to the recipient of the message? FTP, as we talked about, is file transfer protocol. This is how you can transfer files across the network. SSH is one we'll get into later, but this is for securely logging into Linux servers. SMB is another popular one. This is how we can share files on a network as well. Let's talk about different ports on the system. So let me give you an example first. So I want to connect to google.com, but in order to access a certain resource, I have to choose a certain port on that box. So every machine has 65,535 virtual ports. So you have, they can either be open or closed. So we can connect to a service on their open ports. So when you connect to google.com, we connect to port 443, which is the secure version of the website. Port 80 and port 443 are almost always used to access websites. So when we type in google.com, your browser is actually connecting to google.com on port 443. You just don't see that in the background. Okay, and we'll get into more detail on this if this isn't making that much sense right now, but there are 3 different types of ports. So system ports are from 0 to 1023. These are ports that are restricted. So unless you're an administrator on that computer, you generally can't change what's running on those ports. You would need sudo access or system access in order to change that. Registered ports, between about 1,000 and 49,000, these are going to be ports that if you created a program, you could actually run a certain program on that port. So like McAfee antivirus. There are different registered ports that they say, hey, we would like to use these ports to run our program. Now, registered ports can be used by multiple different programs. It's just they're well-known ports. So if you wanted to remote into a Windows machine using something called RDP, Remote Desktop, you'd be connecting on port 3389. That is a registered port. Theoretically, anyone could run something else on port 3389, but it's a standard that most people have accepted that if you're going to connect to something on port 3389, that's just the way it is for RDP, which we'll go over later. Dynamic ports are ports that are reserved for the computer opening up ports when it's sending out a request. So if I want to request something from Google, in order to send that request, I actually have to open up a port so I can listen for the response. So I send a request to google.com on port 443, but I have to open up a port, and it's generally going to be above 49,152. So let's say I'm listening on port 5000 for the response. Google has to reply back to me on that dynamic port. So that's what these different IP addresses are reserved for. Here are a list of common ports. These are ports that a lot of people like to ask on interview questions. So 21 is for something called file transfer protocol. This is how you send files or share files on a network. It's one of several ways. Then we have port 22. This is for SSH, a secure shell. 23 is telnet. This is how you can have different network connections. By nature, it's not encrypted, so it's not very safe. And then port 25 is how email is sent, so simple mail transfer protocol. Then we have port 53. So we talked about DNS in the previous class. This is what port computers use in order to do a DNS query, translating domains to IP addresses. And then port 80 and 443, these are web traffic. 123 is going to be network time protocol. That's how your computer syncs up with the internet to make sure it's the correct time. And then port 3389 is going to be Microsoft Remote Desktop, as we talked about. Now, obviously, there are tons of ports out there, but these are a handful of some of the most common ports. So let's go into another example about when we request a resource. So if we look here, our computer, the client, says, I want dog.jpg. Let's say we're on Google Images, and we're going to request a resource from google.com. So we open up a port, we open up a dynamic port, 49,812, and we're listening for a response on that port. So until then, we send the request, I want dog.jpg, and we send it to whatever this IP address is, 90.12.12.99 on port 80. So if this is Google Images and it has the resource, it says, here's the picture you asked for, and it sends the resource back to us. So it sends it back to our IP address on our listening dynamic port. Okay, so that's kind of a client-server relationship, but now we're getting into more details about different ports that are being opened up and how we're listening for responses. Now let's get into the OSI layers. So there are 7 OSI layers here. There's the application layer, the presentation layer, the session layer, the transport layer, the network layer, the data link layer, and the physical layer. We're going to go over all of these here so it'll make a little bit more sense. So let's start at the bottom here. If we talk about the physical layer, this is how data is transmitted over a physical medium. So think about actual cables or signals or satellite or ones and zeros or electricity, right? This is how the actual data is transmitted across the network. And then we have the data link layer. This is using switches. So switches use MAC addresses in order to transmit data to other devices on the same local area network. So just remember, data link uses MAC addresses to communicate with other devices on the same network. And then we have the network layer. This is layer 3. The network layer uses routers and IP addresses. So routers connect other routers to different networks. Routers connect networks to other networks. And they use IP addresses in order to locate where these different resources are. And then we have the transport layer. So the transport layer is how data is sent. We're going to talk more about these. We'll talk more about the session layer later. The presentation layer is how the data is actually sent. So if it's in a certain format, it's going to be sent to the client. And the application layer is actually how it's presented to us. Now, I know there's a lot of information there. So again, for the application layer, this is going to be what you actually see. So your browser or the website that you see on your browser is going to be the application layer. If you're watching a Zoom link or a video conference, the video that you're watching in real time is on the application layer. It's what the end user sees. Everything below that is just getting it to the end user. So I'd say the most important ones to remember, if you're going to pick 4 from today, remember layers 1, 2, 3, and 7. So the physical layer, the data link layer, which deals with switches and MAC addresses, the network layer, which deals with routers and IP addresses, and then the application layer. The transport layer, the session layer, and the presentation layer, there's a lot of other stuff going on in there, which we will cover, but I think the easiest way to remember this is to focus on those 4. So 1, 2, 3, and 7 for the time being. Now let's talk about something called encapsulation. You don't have to memorize this chart. This is just a visualization of what is happening. So if you look on the right, let's start at the top with the application layer. This is what we're dealing with. Let's say we're opening up Google Drive. So as we send data through the different network layers, we start at the application layer, and then it packages up the data. And then as we send it to each layer, more information is added to the packet. So here's an example again. So we start at the application layer, layer 7. Let's say we're sending an email using Microsoft Outlook. So the application layer, we're viewing an email. So the email is converted from text into data that the receiving server can read. So we're taking it from clear text into a different format. The session layer, so session is opened with the mail server. So now we've connected to the mail server. And then on layer 4, we have SMTP. We talked about this, so this is port 25. So we open up a connection to port 25, and we initiate a three-way handshake. And then we have the network layer, which is going to use an IP address to route traffic there. And then on the data link layer, we're going to use the MAC address to connect to our router, right? Our router is a local device on our network, and that's going to be used to connect to other networks. And then the physical layer is how the actual data is going to be transmitted across the internet. Okay, so today we talked about different ports. We talked about the OSI model, and we also talked about encapsulation here. And then we went over a brief example here. We'll talk more about networking in the later classes, so stay tuned and hope you enjoyed. Thanks.